So in order to understand how to explore and extract petroleum and oil from the Earth, we need to understand exactly how it forms and how it's concentrated, geologically speaking. And so we know that oil forms from dead organic material that was deposited in shallow seas, and then that layer of hydrocarbons was then buried with further sediment. So this is a sedimentary process. And eventually, the hydrocarbons and the sediments on top of that need to be sealed with some type of capping rock that can basically be impermeable so that it doesn't allow the movement of liquids or gases. And generally speaking, when you have a sedimentary process, then all of the layers are laid down in a flat manner. But subsequent deformation of the surface crust can cause changes in the shape of the layers. And one of those examples is here. And you can see that this has been deformed upwards. And if you have a source bed underneath that is a source of oil and natural gas, and you have this permeable layer, then you can have movement of that petroleum product and the natural gas, and it will continue to rise because it is lighter, less dense than the surrounding rock, and it will rise until it basically is captured by the overlying capping rock. And in this case, you have a structure that's capable of permanently trapping the oil and gas. So here are three different geologic mechanisms that can lead to the trapping of the oil and gas. And so on the top left is an anticline, which is exactly what we were showing a picture of before. And below that, on the bottom left, we have a stratigraphic unconformity. And so what we have here is we have the exact same situation. We have a source rock that was laid down with a reservoir rock on top and a capping rock, but there was uplift, and then there was subsequently erosion. And an unconformity is simply missing rock. There is a time gap. So we have essentially the source rock, reservoir rock, and capping rock that have been tilted, eroded away, and then a new capping rock of a much younger age has been deposited to essentially be on top of that, and creates once again a capped system where you can have the capture and retention of oil and gas. In the top right, we have a normal fault. So this is cracking of the subsurface and subsequent motion. And here we have one that is basically moving vertically. And if you have a situation here, you can actually have where it's moved vertically and has created a capping situation in and of itself as well. And the bottom right is a thrust fault, where you can also have the additional capping in addition to the one that was associated with the anticline. So it's really difficult to try and identify these structures underneath the ground, and oil exploration companies have come up with mechanisms to try and identify these different types of geologic features under the ground. And one of the ways that they do that is to use seismic trucks. And so they'll have these trucks that move about the surface. They set off controlled explosions. The sound waves will then reverberate through the rock, and when they encounter different density rock, it will reflect the sound waves and basically cause them to move at different speeds due to the density of the rock. And from these return signals, they can in fact create a three-dimensional map of the subsurface geology. And this is very similar to atmospheric radar, where in the atmospheric radar, you're sending out a beam of radiation that is then bouncing off of targets. Well, here you're sending a sound wave into the ground and measuring the return that comes back, and then interpreting that as different geologic structures. So A lot of people think that you can just go out and drill a well and your drill will go straight down. And if you happen to be over one of these reservoirs, then you've hit pay dirt and or you've hit your target and you'll have a producing oil well. But that's not how they do it at all. So they have this mapping of the subsurface and they have the capability to do directional drilling. So they can have one drill pad, and from that one drill pad, they can drill in multiple directions, and they're actually aiming for specific geologic structures that have been identified through the seismic survey. And on the right, we have an example of a successful well. They have drilled from the drill pad all the way down into through the capping rock and into the reservoir. And you can see that the cross-hatched areas are parts of the well that are actually producing for oil and gas. And this particular well has a lot of surface area inside the drill, essentially the drill hole and the casing has a lot of surface area for the migration of oil and gas into the piping system. And the one on the left, although they successfully hit the reservoir, the amount of surface area in the pipe that is capable of transporting the oil and the gas from that reservoir is limited. And as a result, it would be a non-producing well, or at least certainly not producing at the rate at which the one on the right is actually doing as well. And what you're going to find is that the capability, the ability to do directional drilling has changed remarkably over the last 40 years. And, in the 1970s, they would have a drill pad that would be rather large, and they wouldn't be able to go very far horizontally. But as the technology for directional drilling improved, they can now go quite far from a single drill pad, which helps minimize the environmental impact by minimizing the footprint of the drill pad on the surface. This particular figure basically shows a drill pad that has been established in the water. And believe it or not, this has actually been done successfully in the Arctic Ocean. British Petroleum has built islands in the Arctic Ocean in order to serve as drill pads so that they can access the geologic features that are underneath the ocean. I've actually had the opportunity to visit one of these islands, and I'll be sharing pictures and stories from one of my journeys up there to learn more about the process for constructing these islands and the process for drilling, extracting, and transporting that oil product back to the shore.